So other than making cool fractal designs, what can we do with recursion? Well, here's something that recursion is really good at. This is called a nested list. Now, we've looked at nested lists before. This one in particular has what we would say is it has 3 levels, right? We've got the A names, that's what level 1. We've got the B names, that's level 2, and we've got the C names, level 3. If I take this list and I break it apart into the levels, here's another way to look at it. So that main list, the primary list, has 5 items in it. The first item is the string atom. The second item is a list. It's a 4-part list that has Bob, Barb, and Bert. And in the second index here, or in index 1, we have another list that has Chet and Kat in it. Also, in the 4th spot in the primary list, we have another separate list of B names, B and Bill. There are times, many times in computer science, where you are trying to understand what a list contains. And it looks like this, where it could have hundreds of levels and be very, very complex. This data structure is called a tree structure. And many times, it's your job to write a program that understands that tree structure, how many levels and how many different things are in it and what's in it. But you don't know, because it's so big and so complicated, you don't know how many levels there are or how many members there are or whatever. And so the only way to understand this, it's called list comprehension or tree comprehension. The only way to understand what's going on in this list is by using a recursive function. And it's one of the few things that a recursive function does absolutely better than any other form of code. So tree traversal, tree comprehension is really interesting using recursion. So how would this work? So here's another picture of this list with the indexes on it. How would a recursive code go through this list? So what's going to do is it's going to say, if the item is a name, we're going to count it. If the item is a list, then we're going to call that function using that list. Okay, so we've got the first item is Adam. We count it, that's 1. The second item is another list. So we call the recursive function. We count Bob. We get to another list. We call the recursive function. We count it. And then when that list ends, we go back up, because of the end case causes us to wake up out of that dream, right? And we count those. We end the list. And then we wake up. We count Alex. We find another list. And you can see that the program automatically will go through each list. When it encounters a list, it calls a recursive function. When it comes to the end of a list, it wakes up out of that function and goes back to where it was in the list above it. So you can see here that this is an algorithm that will count any set of nested lists with any shape. And here is the pseudocode for that. For each item in the list, if it's a single item, count that. Otherwise, process it like a list. And so that code is very straightforward. Let me see if I can locate. Ooh, this is hard frozen right now. I'm going to quit it and go back. exit. Every once in a while, PyCharm just freezes up super hard. Okay, so here is the code for counting that list. And you can see it's got a lot of print statements in here. If I comment out these print statements, none of these is actually doing any work for us. So you can see the actual lines that are doing something, very small. So we've got a function called count strings. You can see the list up above. And I've even added some more levels to it. It's got some D names in there. So it's more complex even than the first list. But I've got a function called count strings. And it's going to take an item list and a level. Okay, so level refers to what level of the list are we on. That helps us keep track of where we're at. We start with a count of 0. And it says for each item in the list, if it's a list, then we call the recursive function. If it's a string, then we add 1 to the count. At the end, the post end case is just to return the count back up to the higher level. So when I do this, if I want to use that, when I run that, it spits out 14. 14. So it's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So nailed it. But what's it doing? Let's turn the print statements on so we can follow this recursive function through this list as it does list comprehension. Okay, so let's go back up to the top. So the first thing we do is we start processing the main list. We count Adam, because that's the first number in the list. Then the next item, it says, I found a list. That list contains this whole thing, and that in itself is a nested list. So we start processing level 2, which is this list here. Level 2 has 1 in it. We've counted Bob. And next we find another list. This has Chet, Cat, and then another list inside, Dave and Doug. So we'll start processing that. Level 3 has 1. Level 3 has 2. 1, 2. It's counting those. What about level 1 and level 2? Those each have 1, right? We're just putting a pin in those because we fell asleep into another dream here. We found another list. Now we're processing level 4. We have Dave and Doug, right? When we finish this list, we finally start waking up from the dreams, okay? We do the post end case. So we return those two, Dave and Doug, counted to level 3. So now level 3 has 4 total. Now we wake up from that dream. We return those 4 from level 3 to level 2. Level 2 now has 5. Now we count the last 2, Barb and Bert, right here, Barb and Bert. Level 2 has 6, 7. Now we return that 7 to level 1. Level 1 has 8 total. So we're back at level 1. Let me expose that so we can at least see the main list. We've processed all the way through here. Now we're at Alex, right? Level 1 has 8 total. Adding Alex, level 1 has 9. Then we found another list. The first item in that is another list, so we go down to level 3. We count those 2, Carl and Ken's, and we return those to level 2. Then we count 2 more. We return those 4 to level 1. Level 1 now has 13. So we're all the way at the end here. We just finished processing this. and then we count N, level 14. So it follows those successive levels. It either finds a list or it finds an item. When it reaches the end of a list, it wakes up from that level, and it sends that number back up. Now, I'm not going to make you do anything this complicated.